Video lesson 2.4 tonight is on the formation of ions. This is going to be our first video involving ionic compounds, which we'll get into at the end of this week. My objectives for tonight is that you'll be able to form ions of elements, excluding the transition metals. You will also be able to explain how the charge is acquired on ions when elements' electrons are gained or lost. Before we go into what an ion is, let's quickly recap valence electrons, because this is going to be important for our understanding of how ions form. And so previously we identified that valence electrons for a given family are the same. If you were to look at lithium, sodium, and potassium like we did in class today, you would notice that each of those had one valence electron. And valence electrons are the electrons found at the highest energy level. Up until this point, when we've talked about elements from the periodic table, they've had the exact same number of protons and electrons. If you knew the atomic number, you knew how many protons and electrons there would be. But in the real world, atoms of elements gain and lose electrons to undergo a chemical reaction. And so ions must be formed for a chemical reaction involving ionic compounds to happen. We've previously talked about, as an example, sodium as an element as a metal that's explosive in water. And chlorine gas, which is poisonous to you, forms sodium chloride. It's an example of an ionic compound. Electrons have to be lost or gained in order for that to happen. And so let's begin tonight by looking at sodium as an element and sodium as an ion. And if you were to look at the periodic table, sodium has an atomic number of 11. Okay, and so that's 11 protons and 11 electrons. If we were to draw this out using pluses and minuses to represent our protons and electrons, we would have exactly 11 pluses for our 11 protons, and we would have 11 minuses for our 11 electrons. Now, just like in math here, if you have a positive and a negative, and they're going to cancel each other out. So positive 11 minus 11, that's going to give me an overall charge of 0. So I'm going to write that at the bottom. Charge of 0. Now, sodium as an ion now is still atomic number 11. And it still has 11 protons for it to be sodium. But now instead of having 11 electrons, we only have 10 electrons. And I'll get into in a little bit here why sodium is going to give up an electron. But understand now that we have still 11 protons. But now we only have 10 electrons. And so if I were to cancel out my protons and electrons here, I would find out that I have one more proton than I do electrons. And so if I have one more positive charge than I do a negative charge, this gives us a charge of +1. If I had 2 more protons than electrons, I'd have a charge of +2. 3 more protons than electrons would be a charge of +3. We can also go negative with this, and so if I had more electrons than protons, then I would have that many as a negative charge. Why do atoms of elements, gain or lose electrons? And what that has to do with is it has to do with what's a stable electron configuration for that atom. And that's where the octet rule comes in. And so the octet rule happens when an element, or an atom of an element, has exactly 8 valence electrons. This is the most stable configuration you could have. If you look at column 8A on the periodic table, these are the noble gases that include neon and argon and xenon and krypton and radon and helium also. And these elements don't react with anything. All the other elements on the periodic table have the ability to gain or lose electrons to get to 8 valence electrons. So if an atom of an element is closer to 0 valence electrons, it's going to give up electrons to get to 0. Once it gets to 0 valence electrons, it's now got an empty valence electron shell, or energy level. And so then we'd look at the next highest energy level, which should then have 8 valence electrons. If an atom of an element is closer to 8 valence electrons, then it's going to gain that many valence electrons to get to 8. And so let's look at an example here. If I take magnesium, for example, which has 12 electrons, okay, and I were to write out the electron configuration for magnesium, this would be 1s2, 2s2, 2p6, and 3s2. And if I counted up all my electrons, 2, 2, 6, and another 2 there, I'd have 12 electrons. Now, for my valence electrons, I'm looking at just the highest energy level. And so, for this, my highest energy level is 3, and I only have an s sub level at that energy level. So I'm going to have 2 valence electrons. Now, because 2 valence electrons is closest to 0, magnesium, when it forms an ion, is going to give up those valence electrons to get to 0 in its third energy level with the s sublevel. And so my new electron configuration is going to look like this. And if we know from writing electron configurations before, when I have 3s0 written in there, there's no need to write it because there's no electrons. And so this is just going to become 1s2, 2s2, 2p6. Now, when I look at this now, my highest energy level with any electrons is energy level 2, and I have an s sublevel and a p sublevel. And when we add those up, that's 8 valence electrons. So my ion for magnesium is going to be magnesium with a +2 charge. Let's look at the other side of the table, and let's look at fluorine. And fluorine has 9 electrons. And so when I write its electron configuration, it's 1s2, 2s2, 2p6. For this one, my highest energy level is energy level 2. And I have 2 sublevels in energy level 2. I have 2s2 and I have 2p6. And so I have, oh, this should be a 2p5, sorry. And I have 2p5. So when I add that up, that's 7 valence electrons. And so what fluorine's going to do is it's going to try and gain one more electron, so that it becomes 1s2, 2s2, 2p6 now. And now when we look at it, in my valence electron shell, I have 8 valence electrons. So fluorine, when we write out its charge, is going to be that of a -1. It's gained 1 electron, and so it has 1 more electron than protons now. The last part that we need to describe in this here is cations and anions. And cations and anions are the names given for the ions formed when we give up or gain electrons. So cations give up electrons to have a positive charge, and anions gain electrons to have a negative charge. One way that you can remember this is that a cat always lands on its paws. So cations are positive. And anions, you just have to remember as having a negative charge. That's our video guide for tonight. Come to class prepared tomorrow to practice writing out cations and anions in class. This is going to be the first part that's going to lead us into ionic compounds, where we'll head back into the lab hopefully this Friday.